Okay, so hi everyone. Today we're going to solve this daily challenge, that is 225 triple 25 lead code 5 players with 0 or 1 losses. It's a pretty good problem, and it's a medium problem. I will say, according to the medium level, it's kind of easy medium level. So yeah, it's a good problem, and the like dislike ratio is good. So let's solve this. So we are given an integer array matches, where matches of I is equal to, it will have two values. So every match will have two values. One is the winner and the other is a loser. So basically they both are competing with each other, and one comes out to be the winner and other comes out to be the loser. Indicates that the player winner I defeated player loser I in a match. Return a list answer of size 2. So this answer list will have two elements. The first element will be the list of all the players that have not lost any match, which means that these players have not lost a single match. And answer 1 will be the second part. The second element of the answer will be a list of players who have lost only one match, exactly one. It's not 2, it's not 3, it's not 0, it's only one match. Now these values should be in a increasing order, which means that if we have 1 2 10, you can see they are sorted in increasing order, 4 5 7 8. Now let's see this example and try to solve this. Try to solve. Right, so we have this. So we have this example. Let's solve this example. Yeah, so we have these matches, right? My first thing is that, can I keep a track of the loser and a winner? Right, obviously we can keep a track of their winnings and losing, right? So we don't need to worry about the first element. We are only concerned of the second element, that is the loser. And if this element is, now let's say that I will start iterating over these elements, and if there's a winner, then I will say that in this map it has 0 losses, because it's a winner, right? In 1 and 3, 1 has 0 losses and 3 has lost once, so I will say 3 has lost once. And then I will move to the other element, other match, and in this match I observe that 3 lost again and 2 is the winner, so 2 will have 0 losses and 3 has lost again. Now I will move again and I will say that 3 is the winner now. Wow. But 3 is the winner. That doesn't change the fact that this 3 has already lost 2 matches, right? The matches lost will remain the same, right? If he or she is winning again, it doesn't matter. But now we realize a new thing, and that is 6. So 6 has also lost one match. I will write it here. And then we have 5 and 6. So I will say that 5 doesn't exist in the set, so I will say 5 is the winner and it has 0 losses, and 6 has lost again, which means 2. Now I will say 5 and 7. So 5 is again in the set, again in the map, but it is a winner, so we are not concerned. 7 is the loser, and 7 doesn't exist in this map, so I will say 7 has 1 loss. And then we have 4 and 5. So 4 doesn't exist in the map, so I will say 4 has 0 loss, and 5 exists in the map and it has 1 loss. Now it is basically incremented from 0, now it is 1. And then we have 4 and 8. So 4 exists in the map and it's a winner, and it's again a winner, so it doesn't matter. The losses will be same, right? So this is a losses map, the number of losses of every player. And 8, so now we have 8 doesn't exist, so we'll say that 8 has 1 loss. Similarly we have 4 and 9. So we have 4 and 9. 4 exists in the map and it's a winner, so we are not concerned. 9 doesn't exist, so we'll say 9 is a loser and it has 1 loss. And then we move forward, and then we have 10 and 4. 10 exists in the map? No, it doesn't. So we have 10 as 0 loss and 4 with 1 loss. 4 with incremented, so now it is from 0 it is 1. Then we have 10 and 9. 10 is the winner and it is counted as 0. Fine, but it doesn't matter because 10 is the winner, so we are not going to increment anything. But here we have 9, so 9 has lost already a one match, and now it's equal to 2. So these are the values for 3. For 3, first it was 0, then it was 1, then it was 2, and then it became 3, right? This is a loss, this is a loss, and okay, so there is no 3, there is only 2. Similarly for 6, it became 0, then it became 1, and then it became 2. So now I want to count how many people are there that are undefeated, which means they have 0 loss. So 1 is undefeated, 2 is undefeated, and then we have 10 who is undefeated. So in answer I will have 1, 2 and 10. These are the players that are undefeated. Fine. Now let's see other values. Then we have the player who has only exactly one loss. So in this case, this is two loss, this is two loss, so I'm not going to count it. But 5 has exactly one loss, 7 has exactly one loss, 4 has exactly one loss, 8 has exactly one loss. So I will say 5, 7, 4, and 8. But this order is sorted, but this order is not sorted in increasing order, so we will first convert them. So after sorting them in increasing order, this will be 1 to 10, and then we have 4, 5, 7, and 8, and this is my answer, right? 1 to 10 and 4, 5, 7, and 8. Now how to solve this question? So this is one approach. We can use a map, but while using so we have two maps, right? I think in Java and C++ it's same. We have an unordered map and we have an ordered map. So in unordered map, the insertion, retrieval, everything is constant, but in ordered map, it will be n log n. Now, if I go with ordered map, then I have to implicitly sort them, write the answer. But if I don't go with ordered map, I don't have to sort them, but it still take log n time for the operations. So for every element, it will take n log n time, right? And this method will also, because I'm doing sorting, which is n log n, so this method will also take n log n time. So there is, I mean, you can use map and it will get accepted because the constraint is 10 per 5. Yeah, 10 per 5, it will get accepted. But can we come up with something better? Can we come up with a linear algorithm? Yes, we can. So let's say you have these indexes. Let's say I create a losses, I create a losses vector or an array which contains the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 and 11 and so on up to the highest point, that is 10 raised to the power 5, right? And in these indexes, I will treat these indexes as, so this is an index, this means a player, right? So what do I mean by that? So if we have a losses and this is the I and this is equal to some value, let's say value, then this part will be equal to player and this part will equal to the number of losses that player have, right? So let's fill these values, and the example that we were taking was this one. Let's copy this. Wow. And let's take this one only. Yeah, so this is the example. Right now, let's fill these values. So we have 1 and 3. I will say that, so these values are initialized with -1. So -1 means that there is no player. Right, -1 means that there is no player. But now I say that 1 is the winner, and now I'm at this index and I will say 1 is the winner and 3 is the loser, which means that 1 is 0 now. What does this 0 means? So we have removed -1, which means that this one player exists, although it doesn't have any loss yet, but it exists. So 0 means that it exists. And 3 means the number of loss. So at 3, I will say 1. It has one number of loss. Now we'll move to 2, 3. And at this point, I will say 2 exists, which means it is 0. And 3 has a number and a loss again, which means 2 losses. Then I'll move to this point and I will say 3 exists. And how can I check this? If this value is -1, then I will create this value as 0, but it is not -1, so I'm not going to worry about that. Now 6 value. 6 value is a loss, right? And 6 is -1. So it will be basically 0, that 6 exists, and then it will increment itself with 1. And that's how we calculate the losses till this point. And then at 5, 6, I will say 5 exists and 6 has also lost again, so it will be 2. And then at 5 and 7, so 5 is existing and 7 has a loss, which means 1. Then we have 4 and 5. I will say 4 exists and 5 has a loss of 1, which means incremented by 1. And then we have 4 and 8. So 4 exists and 8 has a loss of 1. Then is 4, 9. So 4 is existing and 9 is the loss. This 9, okay, I forget the counting. What? 9, yeah. Okay. And we have 9 who has lost. So it was -1 initially and now it is 1. And then we have 10 and 4. So 10 is existing, which means 0, and 4 is the loss, and which will it will be incremented by 1. And then we have 10 and 9. So 10 is existing and 9 is the loss, which means it's incremented by 2, incremented by 1, and the final value is 2. Now I will calculate the number of players that have 0 losses. So let's see. So I will start from 0 and I will go in this direction and I will keep on. So these two lists will be created at once, right? So the first value is -1. So it's a 0 is -1, which means this player doesn't exist. 1 is the player who exists and it has 0 losses, which means 1 will be an undefeated player. 2 exists and it has 0 losses, which means 2 will be an undefeated player. And 3 has 2 losses, which means none of the list will have this value, this player 3. And 4 has exactly 1 loss, which means second list will have this value. 5 has 1 loss, so second list will have the value of 5. And then we have 6. No, none of the list will have the value. 7 has 1 loss, so second list will have the value. 8 has 1 loss, second list will have the value. 9 has 2 losses, it's not relevant. 10 has only 1 loss, 10 will be in the first list. And then we can we also need to compare all these elements, and these elements will have, let's say, yeah, so these elements are -1, or there is an element, we will keep it and keep pushing it, and this is our answer. And we don't need sorting in this time, although we are playing a trade-off, and the trade-off is that space will be constant and time value will also be constant, because it will run not constant in a way that it's O of 1, no, but it's O of n. But although we need that it's O of 10 raised to the power 5, which makes it O of 1 theoretically, although practically we know that this is a linear algorithm and it's O of n. And space wise also it's a linear algorithm, because it's storing, because we are using a losses array for this purpose of storing the indexes and their losses as a value. So yeah, these are the time and space complexities. Now let's implement them. So first of all, n is the size of the matches, so I will say matches dot size. Then I will have this vector of int, let it be losses as the name, and the maximum value is according to the constraint is 10 power 5, so I will say 1 2 3 4 5, and the 1 because we need 10, because it can be equal to 10 raised to power 5, and we need that index in the losses array, and everything is initialized with -1. Now I will start from this I is equal to 0, I is less than n, I plus plus. Now I have two players, so one is the winner. Let's create them here. So one is the winner and other is the loser. Okay, I shouldn't write. Let's it be W and L, right? And W is equal to matches of I. The first element is the winner and loser is the matches of I. The sorry, zeroth index is the element, that is first element. Second element is the at first index. Second element is at 1th index. Now if the player doesn't exist, which means that losses of W is equal to -1. If it doesn't exist, then losses of W is equal to 0, which means that it is existing now. And if the losses of loser doesn't exist, which means it's -1, then we will say that losses of loser is equal to 0, that it is existing now. And when we say that it is existing, then losses should be incremented, right? And now we have this array built up. Now we will run from I is equal to 0 till I is equal to 1 10 power 5, which means basically losses dot size, whatever the size was. And if the losses of I is equal to 0, which means this player is undefeated. And now we have a vector of int answer to. So answer first list, right, the first list, which means 0th list, and this will be pushback the ith player. And if the losses of I is equal to 1, then answer of 1 will have this list, answer of 1 list will have the ith player, and then we will return this answer. So we are not sorting this up because we are starting from I is equal to 0 to losses. And what? Okay, vector. God, these typos. and it will not perform well, I think, because it's still taking a lot of time. Even for small cases, if we have only two elements, it will still run for 10 raised to the power 5 time. So it's not a good trade. But yeah, this is the algorithm. And space wise, yeah, it's using a lot of space. I mean, this is also using space, so I don't see how this is an optimized way of, because it's only using 188. Okay, so I'm also using one. I'm also using, okay, so this is 131 and I'm using 188. It doesn't matter. Okay, one and same thing. So yeah, this is the problem. I hope this was helpful, and thanks for watching, guys.